Okay, here we go. My theme today is the importance of strong relationships and how, through a combination of flexibility and persistence, we can address some pretty big problems. So, I'd like to pause just for a moment to thank the many people who've contributed to recent projects, sharing expertise, collaborating on boreholes and well installations, and of course, donating core and providing services. Together, we will be traveling to southwestern Ontario, and that's going to be the area highlighted by the black box. But first, just a little bit of context. Our province is home to nearly 15 million people, and most of them live in the greater Golden Horseshoe surrounding Toronto, which is shown in yellow. And here are the competing demands of an expanding population, industry, agriculture, aggregates, and in the environment mean accurate and publicly available subsurface information is desperately needed to support planning decisions. Focusing on questions surrounding our most precious resource, water, we can consider the roles and responsibilities of different organizations. Municipalities are responsible for delivering water and wastewater services to an expanding population. Conservation authorities manage ground and surface water resources. Consultants play an incredibly important role supporting both municipalities and conservation authorities. And of course, the academic community is focused on the dual roles of education and research. Geological surveys are well placed to work with these organizations, providing the subsurface information required by the hydrogeological community. Interpreted boreholes, conceptual geological frameworks, 3D models, and analytical data are the jumping off point for numerical groundwater flow models. And just last week, we released the beta versions of 3 new cross-section viewers for the Barrie Oro Moraine, Waterloo, and Brantford Woodstock 3D sediment models. And you can access these through Geology Ontario. And Raleigh made up a nice QR code so you can access that directly. Zooming into southwestern Ontario, there's a variably thin to very thick blanket of quaternary sediments, most of which were deposited by glacial ice and meltwater. And on this image, high ground is shown in red and white and lower ground in yellow and green. During the early stages of each glaciation, the ice is relatively thin and individual lobes are controlled by topography. In practical terms, this means ice lobes flowed along the Great Lake basins, as shown by the black arrow. Over time, the ice thickened and the ice lobes coalesced into southwest flowing ice sheets, as shown by the large blue arrow. And then, as the ice thinned, it returned to topographically controlled lobes. And if you look really carefully at this image, you can see there are a series of low, roughly parallel ridges, and these are the moraines. And some of these I've highlighted with the dash line, and they mark the position of the ice front through time. The story doesn't end there, however, as the weight of the ice depressed the landscape and ice lobes blocked drainage, allowing large temporary lakes to form. Zooming in even further, we can see these moraines in more detail. End moraines are composed of till and wedges of poorly sorted sand and gravel dumped along the ice front, and these are shown in green. Other moraines are composed mostly of large underwater fans made up of sand with layers of silt and clay, and these are shown in orange. Many were deposited in large temporary lakes between ice lobes and are so-called interlobate zone, which is marked by a dotted line. Now, while marked as a dotted line, it's really important to keep in mind that the ice lobe shrunk, the interlobate zone got a lot broader, and once those ice lobes no longer blocked the drainage pathways, the temporary lake would have drained. The resulting packages of sand and gravel can host important aquifers and act as pathways for recharging bedrock aquifers below. The story is not a simple one, as multiple advances mean multiple packages of sand and gravel buried with glacial lake, clay, and tills. Over the years, the OGS has worked on mapping these deposits in 3D, and this map shows some of our older published and in-progress projects in white and newer project areas in blue. There are also projects east of the Niagara Escarpment, but we're not going to cover those in this talk. In the next couple of slides, we're going to briefly explore the results of this work following a cross-section shown by the pink arrow. Now, this profile is going to extend from the high ground to the interlobate zone in the west to a much lower Niagara Peninsula in the east. And in this slide, we can see a series of logs from cored borehole data into the top of the bedrock, which is shown in gray. Clay and sandy tills are shown in green, gravel is shown in red, sand in yellow, and silt and clay is shown in light and dark blue. And these colors are going to show up in later logs in this presentation. The correlations show hydrostratigraphic units, which group individual sediment units into aquifers and confining layers. On the left side of the cross-section are older aquifers and confining layers capped with Catfish Creek till, and this is a really important regional marker bed in southwestern Ontario. This till was deposited during the last glacial maximum when thick ice flowed southwest across the landscape, and I'd like you to keep your eyes peeled for this bright green color highlighting that marker bed as we move throughout the talk. As the ice thinned and broke up into lobes, glacial lake clays highlighted in blue and thick sandy fans of the Waterloo and Orangeville moraines highlighted in orange were deposited in that interlobate zone. And finally, progressively smaller ice advances burrowed the flanks of the moraines as shown by the dark green unit, and then deposition shifted away from the higher ground into the interlobate zone into the lower areas around the Great Lakes basins, and these are shown on the right-hand side of the profile. And here we can see clay till and moraines in darker green, and these are buried with glacial lake clay and silt. Now that we've set the stage, we're going to explore the drivers and some very early results from 5 drilling projects in southwestern Ontario. The borehole locations for each project are shown in different colors, and as a very quick reminder, the map shows the moraines in green and orange, and the axis of the interlobate zone is shown by the dotted line. Starting in the north, the first is the Mount Forest Elmira 3D area, which is shown in purple. And here the OGS worked with Kyle and Danielle from Wellington County, Sonia from Grand River Conservation Authority, and Jim from Burnside to drill 4 cored boreholes and convert them into monitoring wells. And this work is supporting updates to community wellhead protection zones and improve the monitoring well network in the northern part of the GRCA watershed. And it's also the first time the OGS has begun a 3D project northwest of that interlobate zone. On this slide, we can see some very preliminary graphic logs and correlations from the cored holes. We hit variably fractured, rubbly, and weathered bedrock, and you can see some examples of the fractured rock from borehole 3, which was drilled near Arthur, and those are shown below. The close-up photo shows both opened and a few sealed fractures, as well as color changes likely related to the flow of oxygenated water through the fractures. The bedrock surface was intersected at depths generally consistent with the existing regional bedrock surface, which is available in MRD 207. The one notable exception was borehole 4, which is shown on the right, and here we hit a buried bedrock valley. By comparison, water wells from the surrounding areas show bedrock at the thick black line. The valley is shown or is filled with lake clays, sediments tentatively interpreted as landslide deposits and glacial till rather than the clean water-bearing gravels that we've seen in other valleys. But some water-bearing gravels were observed higher up in the sequence, and they are likely a combination of interbedded ice marginal diamicton gravels and outwash gravels, and we screened the thickest of those. In the remaining boreholes, we see our regional marker bed, Catfish Creek Till, highlighted by the light green arrow, and this is overlain by thin interlobate glacial lake clays deposited as the thick southwesterly flowing ice broke up into individual lobes. At the top of the sequence is a package of 3 distinct tills, which are grouped into a single upper till hydrostratigraphic unit. And these tills and associated lake clays record small advances and retreats of the southeast flowing Huron-Georgian Bay ice lobe. And you can find out more about this project in Article 19 of the 2025 Summary of Fieldwork Volume OFR 6421, available through Geology Ontario. Moving south into the Guelph area, shown by the yellow dots, the drivers changed to supporting updates to the City of Guelph numerical groundwater flow model and the need to provide water for a rapidly growing population in both the City of Guelph and region of Waterloo. Here, the OGS drilled 9 core boreholes, and 2 of these were converted into monitoring wells by the region of Waterloo and City of Guelph. And I'd like to acknowledge Leslie and Jeff from the region of Waterloo, Albany, Dave, and John from the City of Guelph, and Ashok from University of Guelph, who worked with me in the study area. From a 3D modeling perspective, the focus was on obtaining high-quality data from across the interlobate zone, that dashed line. Most locations were chosen where large sandy Waterloo and Orangeville moraines are no longer evident at the surface. They've been buried, but they may be buried by later sediments. And today we're going to look at 3 boreholes from the Paris and Galt moraine, and that area is highlighted by that yellow arrow. So once again, our regional marker bed, Catfish Creek Till, was observed overlying bedrock, although in borehole 8, it is very, very thin. So from a groundwater perspective, this is quite important, as we've seen that it could be a potential flow pathway between the sediment and bedrock. Fractured bedrock was encountered in these holes, and while it's often viewed as a highly productive zone, Raleigh and I are delving deeper into this story with Ashok from the University of Guelph, and I encourage you to listen into Riley's talk from Tuesday once it's posted on YouTube. The upper portion of the borehole is dominated by a combination of till and gravel consistent with an ice marginal environment. And while at first glance, it is tempting to lump these sediments into a single unit, when we think about their position across the moraine, a different story is revealed. And this time we are looking at sediments which record small advances and retreats of the Ontario ice lobe. So here the ice would have been flowing to the northwest. Located at the most distal position away from the ice front, the sandy till in borehole 10 is marked, which is marked by a dark green arrow. And this is identified by Port Stanley Till and is part of the upper till aquitard. And in the uppermost package of sediment, which is highlighted in light green, is made up of, we're not getting our arrows here. Oh, well. The uppermost package is highlighted just up the top there, and we're going to be seeing some of our ice marginal sands and gravels. There we go. Next, we'll move on to the regional municipality of Waterloo, where a recent drilling and monitoring well installation program by the region provided an opportunity for the OGS to obtain high quality core, which will augment existing data sets. And for this, I am indebted to Leslie and Jeff at the region and Leslie and our hydrogeology team at Stantec. And these sites are shown in blue, and it's worth noting that they are on the interlobate Waterloo moraine. Salina group shale bedrock was intersected in boreholes 1 and 2, but borehole 3 did not reach bedrock because of difficult ground conditions. In this group of boreholes, we see deposits that predate the last glacial maximum. So these older tills are shown in dark green, and thick beds of glacial sand and gravel and cobbles, which form a producing aquifer for the region, are shown in light yellow. And this unit was screened in all 3 holes. Next, we find silty sandy Catfish Creek Till, our regional marker, followed by thick packages of interlobate Waterloo moraine, sand, gravel, and cobbles, which was deposited as the ice broke up in distinct lobes. And it is worth noting that in this portion of the moraine is particularly gravel rich, so possibly ice proximal environment or some of those conduits. The finer beds of sand and clay, so glacial lake sediments, are correlated with the interlobate glacial lake deposits we saw further to the north. There we go. Moving south towards Lake Erie, a coring and monitoring well project investigating artesian flow of methane and sulfur-rich groundwater in Norfolk County provided another opportunity for the OGS to obtain high-quality core to augment existing publicly available data sets. So Anya from Ministry of Natural Resources and Cam, Tazi, and Stu from Montrose Environmental Solutions made this possible. So Dundee Formation limestone was intersected in all three boreholes. And once again, our regional marker bed, Catfish Creek Till, was observed over bedrock. But unlike in topographically higher areas to the north, the bulk of the sediments are glacial lake deposits consisting of fine sand, silt, and clay. And here, ice marginal fluctuations are recorded by diamecton and other debris within clay-rich glacial lake units. Now, the lowermost of these has been identified as Port Stanley Drift Aquitard, and that's highlighted by the dark green arrow. And this unit is a great example of why conceptualizing and modeling glacial systems can be so tricky. Because here the ice advance is recorded by fine-grained diamecton within glacial lake clays, while on the higher ground to the north, the same ice advance deposited stony, sandy Port Stanley till at the top of the sediment pile. So a bit of a tricky puzzle sometimes. Our final project area for today is the Lower Grand River watershed, where the OGS is participating in a 5-year multi-agency collaboration led by Christine from the GSC. And sediment and bedrock coring, monitoring well installations, geochemistry, and downhole geophysics are all part of a much broader project. Now, drilling just wrapped up at the end of January, and during the course of the program, our expert crew were able to core sediments and bedrock at 9 locations, and we installed a total of 12 monitoring wells. And I've got a sneaky peek for everyone at a couple of sites. Tills and thick sands were encountered in moraines in the western portion of the Lower Grand River watershed. This is outlined in black. On the log, the blue triangle shows the unit that we screened in one of our monitoring wells. In contrast, tills and glacial lake clays were encountered in the eastern portion of the area, as shown in the right-hand example. And at this particular location was really noteworthy because we encountered very highly fractured bedrock, and I've put a pink box around that. And this extended through 2 formations. A variety of quaternary sediments were observed within the fractures, and water was encountered in intervals where we think the quaternary sediments had been flushed out of those fracture zones. So in closing, just a few final thoughts. In the past couple of years, I've learned just how important it is to build multi-agency relationships, and I'm still hard at work with this. And this affords us all with the opportunity to benefit from each other's work, whether it's converting survey boreholes into monitoring wells, and even to be able to influence where those boreholes are being drilled, or maybe donating core, which will lead to more reliable regional 3D modeling efforts in the future. So sometimes our timelines are different and the short-term fit for purpose can be enough. But throughout it all, we've learned that persistence and sometimes stubbornness can be rewarded. So thank you. My contact information is presented there.